everybody, how are you all doing today? So, back with Unreal. Yep, my friend has finally returned to streaming again. He right now is closing down his Pega section and will be joining up with me in a little bit. While we wait for him, about a little bit of selling out. Down in the description below you'll find a link to the Pogger shop. There you can purchase energy mixes, sleep mixes, hydration shakers, even stickers. If you use creator code BLACKHEART, you will get a 10% discount and help support the channel in the process. And just in case anyone says, oh, I can hear your fan in the background, I'm not turning that thing off. It is hot for me today. Then it is summer for me. And okay, Jim is getting ready. I'm gonna hop on over to his stage. I hope the stage is already open. Yes, it is open. And wait for him to do his little intro, of which you guys might actually end up hearing because I did activate my desktop audio already. I'm not putting any music on simply because I'm worried that the music might be louder than what you guys can hear. Oh, I just hit my desk.
Started screen, and I will add you to speak in just a minute.
While we wait for him a little bit, let's see. I sort of remember where we left off last time on this whole Unreal stuff. I think it was Quartz overview, which I have no idea what that was going to be about. I am worried about it because it's labeled as advanced. Will we be able to go through all of it? I don't know.
Hey, let's go ahead and get started there.
And there he's doing his
Welcome back to another Unreal Engine study session. I'm your host, Strange Road Jim. We'll be joining here shortly with Blackheart. I see him currently in stage, so I will be inviting him to speak in just a second. But I just wanted to give everybody a little heads up, or also kind of offer my apologies as well. Hadn't done these videos in a few days. I had a death in my family, and obviously I wanted to take some time off.
And the dogs are going mental. God damn it.
It was unfortunate that it happened during the holiday season, so that also hit pretty hard.
I'll be right back.
Correctly saying that it also brought up past memories of my father passing away as well. So it was a hard time for me, so I apologize for being out.
There we go.
And there goes being very sudden.
See, there must be someone outside.
But I mean, if you wanted to, you know, I gave everybody the update on Discord, so hopefully you saw that message and you understand why I needed to take a step away. So, but it's been a while since we did Unreal. I'm not fully remembering exactly where we last left off, so let's go ahead and get Blackheart into this and let's go from there, shall we? So let me go ahead and invite him to speak.
Hello there, Jim.
Hey there, Blackheart. How you doing, brother?
I'm doing okay. How about you?
Better. Doing better. So, okay, so, I'm not really remembering exactly where we last left off.
Last time we finished audio system overview. We had to start Quartz overview.
Yeah, that's what I was figuring that we were at, or at the moment. Hold on a second, let me get the... Yeah, there we go. Yeah, so we finished off audio system overview. Yeah, that's what I figured, but I wasn't like 100% sure where we, you know, were we able to finish that off kind of thing, so
Yeah, that was the last thing we did. We had finished off
Yeah.
that. To be sure, I had looked at our last video just to be safe, but
Yeah.
yep, today we're supposed to start quartz overview.
Okay. Now, I took a look at this a little bit prior, um, and from what I can tell, it's like another application. So it might be talking about things that might not we're not fully aware of. So um,
If it's
so
something
this might
outside of
be
Unreal, we might be able to skip it if it's outside of Unreal.
maybe, again, I don't really know. I don't know whether or not if it's something like completely outside of Unreal, or if it's like a subcomponent or something along those lines. I don't really know. Obviously, as you can see, this is they marked it as advanced.
Yeah.
Um, so this might be covering things that we might not be like fully aware of everything that's going on with this.
Yeah.
So just as a heads up to anybody that's currently watching right at this moment in time. So, so the likelihood of us switching to the audio stream caching overview, the next topic in the list, might be pretty high regarding this.
Yeah.
So, but ready to get started, my friend?
Yep.
Okay, let's get started. So, issues with accurate timing and latency in audio rendering. So in an audio engine, for CPU performance reasons, audio samples are rendered in buffers and submitted individually to output hardware, a digital audio converter, okay, DAC, digital audio converter, gotcha. Okay, so the digital audio converter is the output hardware that it gets submitted to, well, I guess every single time, it seems like. So that's interesting. But good to know. A number of reasons make this the only feasible way to render audio in real time on a CPU. CPU cache coherency, hardware API overhead, and so on. Okay, so I wonder, are they going to go into every single one of those reasons, or are we just going to be kind of left with, trying to figure that out for ourselves?
I don't know. Nor do I know if it'll
Yeah.
be even relevant.
Yeah. Well, I mean, it's good to know what gets put onto the CPU, so you can understand, like, how much is being put onto the CPU, kind of thing, like, what all is being put on the CPU to deal with everything, so if they're like trying to add like additional components onto the CPU that you don't really need, for example, like for example, let's just put it this way. Let's say that you have something that can handle reverb, right?
Yeah.
Some kind of system gets put onto the CPU to kind of check to see whether or not any reverb happens, at some point in time, in your game, right? But
Right.
in our game, we have no reverb whatsoever. Well, we don't really need that, right?
Right.
So, maybe there's a way for us to disable that watcher, so the CPU doesn't need to keep on checking it. You hear what I'm saying?
Yeah.
So, you know, just as a, you know, something off the top of my mind, because it all, it's, you know, sure, it might be great if you have like reverb in your game, for example, right? But if you don't really have it, then there's really no need to check for it, or something along those lines. If there's something like being put on the CPU to check, then you might not necessarily need to worry about it, or you might want to like reduce that amount of time that it checks, or whatever. There's a lot of things that could happen. So yeah, but these buffers typically contain hundreds or even thousands of samples at a time. It is important to understand that audio engine rendering commands are typically consumed at the beginning of an audio buffer render. A command, for example, might be to play a new sound, stop an old one, or change the parameter of a sound like volume or pitch. Because of this, the size of the rendered audio buffer directly controls the rate at which new commands are consumed. This rate also describes the perceived audible latency of any issued commands. For example, if you were to trigger an explosion VFX and an explosion sound in the same game thread tick, the latency between seeing the VFX explosion and hearing the sounds is determined by this buffer size. Okay. So determined by buffer size. Okay. So I take it that if the buffer size is smaller, the latency might be smaller, and therefore you might be able to hear it faster, or it doesn't really state that outright in this. I'm assuming like the latency that they're talking about, being determined by buffer size. I guess the larger the buffer size, the more latency you might have. Maybe, because it might take a long time to kind of process everything inside that buffer.
Maybe.
I doubt it's like the other way around. Like there's a huge amount of latency for a very small buffer. Kind of feel like that's probably not correct. Probably. I mean, I'm just guessing. So.
Give me a second, John. I'll be right back. I need to do something about my dogs. And I tell you, that dog's missing a few brain cells. He's barking at nothing. I'm gonna mute everything just in case. So I'll be right back.
No worries. No worries. I'll maintain the fort here. So. So in other words, if something was to have like a very large explosion or something that would, that might take like a long time, like a long explosion sound, or like maybe like multiple explosion effects or something like that, right? You try to create the sound that, maybe there's like multiple explosions happening, all at once, then, or you might need to add like some additional effects into it, or something, right? So maybe you're adding all these different sounds into your buffer, for it to kind of process all of it all at once. So for example, if, um, you know,
Okay, I'm back.
welcome back. I was kind of talking about like, the latency and the large buffer size. So if say like there's like multiple explosions kind of back to back to back kind of thing, like you have like a chain reaction, like boom 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 boom, like all like kind of tied together, so that you're just kind of having it play through that entire audio sequence. Say like, you played Subnautica, so so have I, for example.
Yeah.
This ship explosion, right? Not exactly something that is having like multiple explosions all at once, but the fact that you had a lot of like reverb to it, a lot of echoing to that particular sound. Um, so you know that that obviously gets put into a fairly large buffer, and obviously the amount of time that it might take to handle said sound might require you know might need a little bit of time for it to kind of render all that and process that, right? So it'd be a little weird to try to time it, uh, mess up the timing so that like visually you might see the explosion, but you hear the explosion like 10 seconds afterwards or something like that. It's like, what happened to the audio? That kind of thing, right?
Right.
So it might be a little odd if that was the case. Okay, so this means that the buffer that contains 2048 samples, rendered at 48K samples per second, the buffer would result in an audible latency of up to 43 milliseconds. Okay. How did they come to that calculation?
I wouldn't know what the equation even looks like.
Yeah. Well, I mean, you have 2048 samples at 48,000 samples per second, right? So you'd basically be taking the 2048 divided by the 48,000, and that should give you the 43 milliseconds. I mean, right, to a proper calculation here real quick. I wanna confirm that real fast. So divided by 48,000. Yeah, 0.0426666666.7.
Yeah, and it's just rounded up
So
to
yeah,
43.
yep, 43 milliseconds. So okay, interesting. Okay, so now, is it always going to be the 48,000 samples per second, or did they just kind of pull that number out of anywhere? That's I'm not sure about that. But
I guess it depends on the buffer or something.
well, the buffer itself is containing, they say is the one that contains the 2048 samples. So the buffer will change in size on the number of samples, the number of audio samples and stuff like that. So obviously, that 2048 might change, um, depending on what all you need to have like as a sound, right? Your explosion might have like a lot more samples to it. It might contain like 10,000 samples. What I'm kind of curious about is, they give the 48,000 samples per second. I wonder if that's like their standard, you know, um, like for example, if you have a buffer that somehow has 48,000 samples, you know, would it actually, would the latency be up to 1 second because it needed to take that long to handle all of that? You know, does Unreal Engine require that 48,000, or does the Unreal handle 48,000? I don't know. We'll find out, I'm sure, but at some point,
Eventually.
maybe that's not. That might not necessarily be a standard value, but I don't know. We'll find out. In addition to this inherent latency with the audio renderer due to the render buffer size, audio commands issued from the game thread take time to get to the audio engine due to game thread and audio thread ticks, and general thread communication overhead. If a threading or gameplay latency is 13 milliseconds, a feasible number, and we use the same buffer size of 2048 samples at 48 kilohertz, and if the command must start just miss the start of the current buffer being rendered, there will be a worst case accumulated latency of 56 milliseconds. Now, here's the thing that I'm a little concerned with here. Up above here they talked about the 48K samples per second kilohertz, right?
Right.
But down below they just say 48 kilohertz. So are they kind of skipping the whole K label down below? Because K is kind of already put into kilohertz,
Yeah.
thousands. So because they have 48 kilohertz there already, they're already saying, you have 48K per second. I'm assuming that's the case because they're basically saying, hey, the 2048 samples at 48 kilohertz is taking up to 43 milliseconds. And then you have a threading gameplay latency of 13 milliseconds. So combined total of those two would be the 56 milliseconds. That's what I'm assuming. So, because you're just adding the 13 to the 43, and that's what gets you the 56. So, but again, I'm making the assumption right at this moment in time that these two labels here, the 48 kilohertz and the 48K samples per second kilohertz, is the same. I'm making that assumption. It should be a fairly easy assumption to make, but
it does make
if
sense.
I'm wrong for some reason, then okay, what's going on here? But I'm assuming that I'm right on that one. Unless, of course, you can figure out something that I missed there.
No.
Blackbird.
No. No, I can only assume where those 48 kilohertz came from, that's all.
Yeah.
I'm assuming like the CPU would be these 48.
Yeah, I'd have to wonder, like, where exactly is the 48 kilohertz coming from?
I'm
Or
assuming
what?
it's the CPU in this case.
Right, but at the same time, um, here, I'll check something out here real quick. Because normally when you look on your, when you look at your properties for your CPU and stuff like that, like if you look at your processor, right,
Right.
you'll see something, there about, how many hertz you have
Yeah.
for your processor, right?
Right.
It might be, it shouldn't be kilohertz anymore.
No, but they're using this as an example, I'm guessing.
Yeah,
Although then there
uh,
is the CPU cache, which that one is slightly different.
right, right. Well, I mean, the cache should help you out in that regard as well. Um, so, um, like for example, an i9 um, 12900K has a processor, has 3.19 gigahertz. So is that going to basically mean that, it could process, um, 2,000 samples really, really quickly?
Technically speaking, yes.
you know, one would imagine, right?
Yeah. Depending on how
Um,
much load you're putting into it. After all, some of those
right.
gigahertz are going to other tasks.
Sure. Sure. Um, so, for example, if I had, I'm gonna pull out the calculator again. So if we had that 2048, samples, and I had the, um, 3.19 gigahertz, right? So, um, let's see. So that is billion. So yeah. Um, so I'd be looking at a point zero, well, about 5 zeros, 6.42.
Almost
Well, I mean,
nothing.
I have 6.42 e to the negative 7, according to according to this calculation. Um, so so not that long at all
Nope.
in that kind of regard. But again, it all depends on, once again, how much it might be tackling. It might be tackling, something else, as well. And that's one thing about, the CPUs. It's handling a lot of different tasks as well. You open up your well, you open up your task manager and you look at, CPU, you look at your memory being used, and, you notice a lot of processes that your CPUs, you know, might be tackling, maybe not necessarily at that moment in time, but it might still be kind of understanding that there might be something going on, right then and there, right? So, or it's kind of looking at those processes to make sure that it can handle those at that particular moment in time without too much latency.
Yeah.
you know. So Alright. If an audio request comes in after the buffer has started to render, then the request 1, the request will carry forward without playing. 2, until the beginning of the next buffer 3. To complicate matters, game thread ticks are highly variable, at least from the perspective of an audio renderer, and are often susceptible to arbitrary hitches during garbage collection, loading assets, and so on. Game thread ticks are also timed for gameplay and graphical rendering, not for audio rendering and audio timing. If you need to play a sound at a precise moment in time, exactly when a different sound is finishing or starting, calling that command from the game thread will not work because the game thread and audio renderer thread event timings are decoupled. So that's that's going to be like the interesting point in this, like trying to make sure that your audio syncs up with your visuals, right?
Yeah. Yep.
If you're like doing a like a shooting game, for example, right? And you're clicking on your mouse or something like that to fire, you're firing your gun, so on and so forth. But the audio for that, like you pull the trigger, your gun pulls back a little bit to kind of show that you're shooting off your round, so it's slightly the gun moves because of the basically the force of the projectile firing off, right?
Right.
So unless you have a really steady hold on it, which not many people, to my knowledge, I don't think many people would really recommend that very much. Otherwise, you're going to be like hurting your hand, arm, shoulder, whatever on that. You kind of want it to move a little bit.
Yep. Some recoil is necessary.
Yeah. But if your gun goes off, right? If like you fire off a round, right? Bam. But that bam, that gun sound doesn't go off until like a second later. It's like click, gun moves, bam. It's like you're gonna be like going, what? What's going on here? This doesn't make any sense. It'd be very confusing for the player, right? So you obviously want to make sure that you try to time it together fairly well, but they're obviously stating right now that it's not as easy as you might it's not as easy as you might think, and believe me, I agree with them.
Mm-hmm.
Because if like the nowadays with the graphics card, it's the graphics card is handling a lot more of the graphical details. So you might have a graphics CPU that's handling a lot of that, the workload. So your regular CPU might be handling everything else, and trying to time up your audio with your graphics might be a little rough, so, but yeah. These issues are of variable latency and game thread dependent timing of audio events are not significant for the majority of audio applications. Depending on the CPU load of a game or the constraints of a particular platform, it is usually possible to tweak the buffer sizes and number of buffers rendered ahead of time to a size where most timing issues are below the threshold of perception. One would hope.
Yeah.
But again, below the threshold of perception. So, So our perception might not be that high ourselves, but if you like were to like analyze it, for example, using state-of-the-art uh, audio techniques or something like that, you're like really having the computer analyze the audio versus the visuals kind of thing, and going, is this actually true? Then it might go, well, no, not really. The timing is off. You know. So. However, for some audio applications such as interactive music, precisely timed repeating weapon fire, or other rhythmically dependent audio, these issues are a significant problem. Indeed.
Yep. A rhythm game's worst nightmare.
Mm-hmm. So chords and sample accuracy. So sample accuracy is the ability for a sound to start at an arbitrary sample in the audio renderer, such as middle of a buffer, okay, instead of the buffer boundary. Interesting. Quartz is a system that works around the issues of variable latency and game thread timing incompatibility by providing a way to accurately play any sound sample. Sample accuracy refers to the ability for a sound to render audio at an arbitrary sample point in time within an audio buffer rather than the beginning of the buffer. Okay. So Quartz provides a way of scheduling an audio call mid-buffer instead of having to delay the audio render until the beginning of the next buffer. Okay, so this might seem interesting because so from what I can gather on this, like say say you have something that is kind of like maybe you want maybe you have a multiplayer game. Let's give this an example, right? You have a multiplayer game, someone enters a bar, goes to a jukebox and starts playing a song, right?
Right.
So the one player's going, oh yeah, listen to the song, maybe they're dancing or something like that. And then the second player enters said bar. They didn't hear the song, at the very beginning. They came into the bar later, right? So obviously that second player shouldn't necessarily be hearing that song at the very beginning of that song, right?
Right.
They would be hearing it at that particular moment in time for that song. So, the first player might be like, enjoying the song. They're probably like about a minute into the song or something like that. And that second player comes on in, and well, should the second player start hearing that song from the very beginning? No, they shouldn't be, right? Because if they're like, talking with the first player, they're going to be like, oh man, I missed this part. Or, and they should be like, oh man, the very beginning of the song was my, favorite part of the song. Damn it, I missed it. If it started at the very beginning, then then they'd be able to catch it. You'd have a different interaction at that point, right?
Right.
So Quartz in this particular case might be very handy in that regard, because now instead of timing the second player's audio to the very beginning of that buffer, that song buffer, they're now kind of timing it to where the buffer, where that buffer is at that particular moment in time for the song that the first player is hearing, and giving it to the second player. You know what I'm saying?
Yeah.
So that might be interesting, Obviously, might not necessarily, might not necessarily be necessary a lot, but I could see its uses. So, instead of rendering a sound at the beginning of the audio buffer, course cues the sound to play on the desired music value, bars or beats, or time value, seconds, independent of the buffer size, game threading, timing, or other sources of variable latency. This has many applications, from creating dynamic music systems, definitely, to controlling the playback of rhythmic or timing-dependent sounds, such as a submachine gun gunfire. Okay, interesting. How Quartz works. With Quartz, you can give the audio engine advance warning by scheduling a sound with play quantized, okay, which executes the play command at a specific sample in the audio render. By scheduling ahead of time, you account for the delay so that the sounds can render on exactly computed samples to make the queued up sounds play as though there were no delay. The buffer size is also referred to as the audio buffer callback size, or callback size for short. Okay. So, A represents the game thread with x-axis demarcations indicating game frame ticks, while B represents the audio renderer thread with x-axis demarcations indicating rendered audio buffers. Their respective x-axes vertically line up in real-world time. One, when the game thread calls play quantized. Okay. It requests that the sound be played on a given quantization boundary, such as the next quarter note, as calculated to the nearest audio sample, output sample on the audio render thread. 2. Quartz issues this request in the form of a generic quantized command and keys the sound for audio rendering at a future point in time. The request is held through multiple audio buffers on the audio renderer thread. 3. By the computed amount. When it is time to render the sound in the computed buffer, Quartz feeds the audio through an integer delay that prevents it from rendering at the beginning of the buffer. 4. And instead renders partway into the output buffer on the sample needed to play exactly on the quarter note 5. Interesting. Alright. Any questions so far? Or?
No.
Quartz also works with blueprints. Blueprints provide a way to apply these quantized commands and timing events, which in turn trigger gameplay logic in sync with the quantized actions occurring in the audio mixer. One would hope. Okay, main components of Quartz. Quartz clock. A clock is the object in charge of scheduling and firing off events on the audio rendering thread. The clock is created with the Quartz subsystem and modified via a blueprint using clock handles. Each clock has a Quartz metronome. Quartz metronome is the audio renderer thread object that tracks the passage of time and decides when upcoming commands need to be executed from user-provided information such as BPM, beats per minute, and a time signature. Gameplay logic can subscribe to events on the metronome to be notified when musical durations occur. Okay. What's the clock handle? The clock handle is the gameplay's side proxy of an active clock. This is acquired via the Quartz subsystem and used to control the clock running in the audio mixer. Okay. Not quite sure what that's all about per se. on.
Sure.
Quartz subsystem. While a clock handle provides access to functionality on a specific clock, the Quartz subsystem provides access to functionality that does not relate to a specific clock. This includes creating and getting clocks, seeing if a clock exists, and querying latency information. Okay. So the clock handle is more like it sees whether or not there is a need for a clock, I take it. You know, grabs that clock so that it can be processed and then runs, you know, whatever it needs to run through the quartz at that particular moment in time. Maybe. Whereas the subsystem handles anything else, you know, creating and getting clocks, seeing if the clock exists. Or maybe I'm wrong on the clock handle.
Not entirely sure.
Well, maybe we'll find. Maybe if we ever need quartz, we'll find out more about what's going on here, or maybe we might need to look at more of a quartz tutorial later on, but that will probably have to be handled later.
Yeah.
I'm not saying that we're probably going to be needing quartz right away. This sounds like you're going. I love when my headset likes to give out on me all of a sudden.
No.
Sorry about that.
No problem.
So, where was I?
No. About using quartz.
Yeah, I don't think we're going to be needing to use it all that much, or we're gonna need it for like our first
For our first
for our
few
first
projects
clone or,
might not rely on it.
yeah, right, because that's it. It sounds like you'd probably want to use quartz when you're dealing with things that, you know, might require the sound to be played like in the very beginning, like, you know, in the middle of a song or something like that. Like, for example, like if we're playing a if we build like an RPG, for example, right?
Right.
And we have the main character go into a bar. You know, like someone's playing the piano, right?
Right.
Well, obviously, it'd be kind of silly for us to go, oh yeah, the piano player happens to be playing, you know, the very beginning of the song right then and there as soon as you walk in. It's like, what timing? No, probably not.
No.
So you might need to do like a quartz at that particular moment in time, right?
Yeah.
You know, maybe. You know, I'm just giving it as an example. You know. But you know, it's like how like certain like animes, for example, they like to kind of take snippets of songs and kind of put them into their anime or something like that. Like, you know, like anime openings might have like a couple, like a minute of a 3-minute song at the very beginning, you know, so, you know, you just might not want to play like the entire song, you know, that kind of thing. So, as an example. So, audio component, play quantized. This is a new function added to audio components that provides a way to play a sound on a specific clock with a specified quantization boundary. So creating initialize quartz clocks, blows the sample workflow to create a clock. Hmm. Sounds like, something that you can do to try to, try to build something using blueprints and whatnot, but we haven't really done too much in terms of blueprints anyway, so I would say this might not necessarily work for us right at this moment in time.
Yeah. Because
That
this
particular
involves us
section.
creating our own clock to apply quartz,
Yeah.
which we don't even know if we'll even deal with that anytime soon.
Yeah. Same with the play sounds on our quantized boundary
Yeah.
section here. Sounds like it's kind of going through. This might be great if you want to like try to use quartz for the very first time, kind of thing. Like, this might be kind of helpful. This might kind of show you how to go about, creating, the quartz at the very beginning. But obviously, I don't think we really need to worry about it too much right at this time.
Us? No.
Yeah. Now, obviously, if we get to a point where we want to use that effect, then we'll probably need to kind of come back to this. We'll need to kind of remember this later on in the future, hopefully.
Yeah. We
And come back
find
to it.
ourselves in need of it, and yeah, we'll probably have to come back to it.
Yeah. We'll have to remember that such a thing exists to come back and use it and all that. But I don't think we really need to kind of move on with the remaining sections because it's all about kind of building it and like discussing what it's all doing.
Yeah.
At that particular moment of time, and I think that we could probably save that for if we ever need it in the future.
I'd say so, yeah.
You okay with that?
Yeah, I'm okay with skipping it.
Okay. So, next session is the audio stream caching overview, but we got about like 4 minutes left. So I'd say that let's go ahead and save this for tomorrow.
Yeah.
Because obviously there's a lot here. There's also a lot of commands and stuff like that through this from what I can see, so this might be getting into very interesting processes.
Yeah.
A
little bit of sound mixer and a little bit of coding.
Yeah. Interesting. I'm looking at an image that they're showing for the stat audio streaming. So that's interesting. Alright. But yeah, let's hold off on that until tomorrow. So
yeah,
that's where we're gonna go ahead and close on out for our Unreal. So I want to thank everybody for stopping on by and watching this with us, joining us on our journey through learning Unreal. If you have any kind of tips and tricks for us, feel free to leave them in, our chats or in the comment section when we upload these to YouTube.
Yeah, and if we understood something wrong, do correct us, please.
Indeed. Because we're starting out. We're noobs.
Yeah, and we're not audio engineers.
That's it. We're probably gonna get things wrong. Or maybe the Unreal documentation is off in some way. It's hard to say. We don't really know. So, we welcome any kind of, constructive criticism, advice, what have you. So. Um, but yeah, I think that's going to be it for this, though, my friends. So, now you're going to be taking a break so you can get yourself some food,
Yeah,
I'm
I'm gonna post
assuming.
down, get some munchies.
Yeah. And then you're going to be coming on back later on tonight to play what again?
I'm gonna be playing some Genshin. Gonna finish up the event. Right now,
Okay.
all of it should be available. It's one long event. I will do tell you that for when you get into it next time.
Oh, so in other words, my Sunday is probably going to be
All
completely taken
event.
by it. No?
Yeah. Well, the first 3 parts of it took me an entire stream.
Oh, wow.
Yeah, it's long.
Okay. Well, then we're probably not going to be doing much in terms of co-op on Sunday then.
Yeah, well, I don't know if I'll be streaming on Sunday since it's New Year's and my dad's birthday. So I might do it on Saturday instead of the Genshin stream.
Gotcha. Okay. That's fine.
Then I'm in charge of the
I'm-
barbecue.
No, sure. I'll probably do. I might do a New Year's stream. You know, but obviously it'll be interesting. You know, it might be a little too late for you to kind of stay up with me watching my midnight. So, then that
I'll probably be asleep by
you know,
then.
yeah, that would be like 5 o'clock in the morning for you.
Probably.
So, um, but yeah, but I might do that anyway. I don't know. We'll see. There's a lot for me to kind of catch up on, seeing that I haven't. I've been gone for a while.
Yeah.
So, but yeah, okay. Tonight for myself, I have. Well, I'm gonna be doing some more video uploads in just a second, and then I'm gonna start up the new game, the Lego Movie video game. Um, last time I was trying to do the XCOM, and it glitched out on me pretty badly. To the point where none of my soldiers were able to fire any of their weapons. I'm like going, what's going on here? Now, I got a message back saying that, hey, you need to clear out your cache and, check your game files for any kind of problems. That should fix the problem. I'm like, okay. But, I made the announcement that I was going to switch on over anyway, so. Well, so.
Maybe later on in the future.
Yeah. I'll, once I'm done with the Lego game, then I will, I'll, make sure to do a full clean, check, game, game check, game integrity.
File integrity.
Before I play the game again, and then we'll go from there. But I made the announcement that I would switch over to the Lego Movie video games, and that's what I'm gonna do. So, but I'm gonna go ahead and stop my video recording now.
All right.
There we go.
I'm gonna just go on and get myself something to eat.
That's good, my friend.
Once I'm back, I'll finish up that event and try to get my hands on as many primos as I can. I really want the new character.
Okay.
It's really good.
Okay. Yeah. I haven't had a chance to see the new characters, obviously. But yeah, and even then, the previous characters are already gone.
Yep.
So yeah, so I missed out on that. I think I was watching I try to lurk on your streams. I tried to lurk on your streams when I could, and I think one of your commenters were saying, don't worry about Zeno, he's crap, or something like that. So,
Sino, yeah, they were saying
yeah,
that. And
I know.
it's like a better version of Racer, which he does. He does play a bit like Racer. He just hits harder. I
Yeah,
did still try to pull for him. I ended up getting Mona instead.
yeah. I heard that you got her, so.
Hmm.
And interesting that you got Mona off that banner, seeing that she wasn't being offered, but.
It's not the first time.
True.
I mean, I got
True.
D-Luke on Linnea's banner,
Right.
which is weird. I mean,
Yeah.
why making these 5-star characters unlimited banners? I would understand it in the regular one, but the limited one? Where do these guys come from?
Well, I mean, they still offer those 5-star characters in those banners anyway, but obviously, they're supposed to have a lower chance. But the fact that it's like, hey, you got a 5-star. It's like, great. Yay, we're getting the, 5-star, main character. Nope. It's like, wait, what?
Where did this one come
Yeah.
from?
So.
I can already hear the meme on the back of my head say, wait a minute. Who are you?
It's like the, those typically, who's that Pokemon? Because they don't show you, like, immediately
Nope.
who the character is, right?
Nope.
They have that, like, the outline of the character first, and then they, bam, there goes, right?
Yep.
So it's like, you look at it like, going, wait, that doesn't seem right. It's like, yeah, I'm rolling for this male character. I'm rolling for this male character. Wait a second. That outline looks very female-ish.
Yep.
It's like, I have a funny feeling that there might be a slight difference there. Just I can't seem to put my finger on it, but that outline right there does not look like the character that I'm rolling for there, guys. Just saying,
Yeah.
I don't, I've heard about Mona, but I haven't seen her in action all that much,
No,
so I
I
don't know.
haven't used her yet. They tell me she's good, a good support, but I haven't used her.
Right. So.
But now I have another Hydro 5-star.
Oh my god, another one?
Yep, that's... I got Nuvula, I got Farina, now I got Mona. Give me a different
Mona's-
element, please!
I can understand that one.
Yes, the reason why I didn't go for Ayato, because he was also Hydro. I mean, I got enough of them.
Yeah.
Fortunately, on
Okay.
the one, it's the new Geo character and Ayaka, Cryo character.
Okay. What's the new characters? Oh, Geo, you said.
It's a Geo, and it's a heavy hitter.
Okay.
Okay. I
So,
am
I'll
off
let you go
to
so you
some
can get some food.
Mhm.
So, you have a fun time with Genshin, and I'll catch you later.
Take care.
Okay.
Bye.
See you next time. Bye.
Okay, there we go. I was like, why am I not? Why is things not working? But there we go. I am out of there, and yeah, I'm gonna stop the stream right here. I'm gonna go get something to eat, and then I'll be back in roughly an hour for some Genshin Impact. Why don't I just put it on, be right back, I'm getting some food? Because I don't like eating on stream. Simple as that. If I ever do that, it'll be during like a subathon of some sort. Once I get, if I ever get to that point. Who knows? Maybe once I get my like affiliate on Kick, I'll do a subathon for Kick. I don't know. We shall see. But anyways, so thank you all for watching. I hope you enjoyed today's stream, and I hope to see you all in a little bit. Bye bye.